All right, pre-calc kids, let's finish up this section. All right, so now we're going to look at the explicit formula for the nth term and how we can make it look more like function notation and how they relate to each other, okay? Make sure y'all read these. It's important. Read it, learn it, love it, okay? So we're going to give you this sequence, okay? I know it's not arithmetic because it goes up 3 by times 2 each time, right? And look at this. It doesn't make a line. It makes a whoopsie shoodles. All right, it makes a curvy derby. So I already know how to fill out these. We did it earlier, right? A sub 5, A sub 6. I'll do this one right this time. A sub n. And over here, A sub 2 is the same thing as F of 2 when I plug in 2. And that's the same thing as F of 3 when I plug in 3. And F of 4, see? And F of 5, eh? And F of 6, okay. And F of n, okay. Jiminy Crick, how do they keep me around? How do I maintain employment? Alright. Are we good on that? Now over here, we're just copying the terms from up here, right? Or from the graph. 3, 6, 12, 24, 48, 96. Not so bad, right? But remember, F of 2 is the same thing as A of 2. And we get that is our 6. 6 is A sub 2, which is F of 2. They're all kind of the same thing. So now to write this in subscript notation, I'm going to drop my pen and make a big noise. I'm going to do my A sub n equals my A sub 1, which my first term was 3, times my R, I should have wrote 2. My R, which for this one, my ratio is 2 to the n minus 1, right? Now for function notation, I'm going to do f of n equals, watch this guys, it's going to blow your mind, 3 times 2 to the n minus 1. They don't change. Who'da thunk it, y'all? Who'da thunk it indeed? Any questions on that? Can't hear you anyways. Let's keep going. All right, let's look at 12. Ooh, a half-life problem. I love it. You'll love it, you'll love it, you'll love it. I could have probably done this one in class. All right, write the first 6 terms of the sequence. So my first term, again, am I plugging in 1? Yeah, plug in 1. So when you plug in 1, you get 6. Now again, I could plug in all my terms. I know 6 is the first term because that's my A sub 1, right? Now, from here, I could plug each one in, but I'm just going to say, what's 6 times a half? 3. What's 3 times a half? 3 halves. What's 3 halves times a half? Multiply the bottom by 2, right? 3 fourths. What's 4 times 2? 8. Because that's what I'm doing, multiplying the bottom by 2. What's 8 times 2? 16. That's my first 6 terms. Now, let's find the A sub O term and support it with work. So A sub O means I'm going to plug in O, or 0 as y'all call it, to my equation. Okay. 0 minus 1 is negative 1. What's 1/2 to the negative 1 power? Well, remember negative powers, you bring it to the bottom or you reciprocate it. You make it the reciprocal. So it'd be 6 times 2, which is 12. So that's our A sub O. Okay? And what my exponential formula be then? So if I want to make this an exponential, I don't use n minus 1. That's what makes it different. We're going to start to transition here into exponentials. So I'm going to do my f of n. And that's going to be equal to, now before I used a1, right? If I use AO, I can get rid of the n minus 1. So I'm going to do f of n equals 12, my A sub O, times my rate to the n. That's the same function as 6 times 1/2 to the n minus 1. They're the exact same thing. If you don't believe me, graph them both on your calculator. I guarantee you won't. Y'all are lazy. I'm just kidding. You're not lazy. I take that back. You wouldn't be in this class if you were lazy. Okay? Only teachers of this class are lazy. All right. All right. Let's talk about Tim. My dad. Hey, Dad. Helium balloons. Dad, why are you doing this, dog? All right. So he has a balloon. It rose 200 feet in the first minute. And then in each minute after that, drops 50%. Write the formula. So, my first time ever that I'd measure it would be 200 feet, correct? That's my initial. Now, 50% is 0.5. And I can use 0.5 or a half, right? And then I'm at minus 1. There we go. Now I can use that it says to use the formula. I wouldn't to fill out the chart. If I want to know how high is the balloon at 4 minutes, I would plug in 4 for n. But so what I'm going to do is what's half of 200? 100. What's half of 100? 50. What's half of 50? 25. What's half of 25? 12.5. What's half of 12.5? 6.75. It's half of, or I'm sorry, 6.25. I can math. It's half of 6.25. 3.125. What's half of that? 1.5625 feetsies. So, yeah, that's how much it rises each time. Now the question is asking us, how high is the balloon after 8 minutes? Okay, so this is how much it rises each time. So it started at 200 feet, and then we added 100, then we added 50, then we added 25, then we added 12.5, then we added 6.25. Then so we add all those numbers up, and in 8 seconds the balloon reaches 398.4375 feet. Uplifting problem. Okay. So far, okay. So again, we add these up because we want total height. That just told us, the equation gives how much it went up each time. We're getting into physics. We're getting close to calc world. Okay. Big Tech Electronics. That's where I buy all my stuff from. Good old Big Tech. Says it'll be $50 at the end of the first month, $55 at the end of the second, $60.5 at the end of the third. So what will the payments be in the 4th, 6th, and 10th months? Oh, enchanté. So we've got to find that rate it's going up by each time. So what's my rate? So if I do 55 divided by 50, I get 1.1. So the rate it's going up by each time is 1.1. So if I want to do this right, my formula would be 50 times 1.1 to the n minus 1, correct? Right? I found my r, plugged it in. My a sub 1 is 50. So my a sub 4, I'm going to take that 4 and plug it into this equation, right? It'd be 50 times 1.1 to the 4 minus 1. And when I do that, I got $66.55, or $66.55. I know how money works. I know I don't have any, but I know how it works. So my a sub 6 is, I'm going to plug into the equation, I get 80.52, $8.52. And my a sub 10, I'm going to plug 10 into the equation, and when I do that, I get $117.90 or so. Jiminy Crickets, sorry for the language. They're going to bleep, bloop, and blop me out here on this YouTube machine. Stop it. Whatever, this is what it is. This is my life. $117.89 and no cents. All right. how much will a customer pay for the tablet on this payment plan? And because they have to do this for 1 year. Oh my gosh. So what I have to do is take my A1 plus A2 all the way up to A12, right? Because that's my monthly cost each month, right? So I would do my $50 plus my 55 plus my 60.5 plus my 66.55 plus a bunch of tedious work, which we get by plugging in our formula, or you can just take each one times it by 1.1 and make your list. When you add all those up, you can check it. You get $1,069.21. That's like a yearly salary for me. It says write it as a geometric sequence and an exponential. Well, we wrote it as a geometric. Do you guys agree on that? It's right here. A sub n equals 50 times 1.1 to the n minus 1. Now, can we write that as an exponential? Uh-oh. For this, I need to find a sub o. Uh-oh. Well, to find a sub o, I gotta work backwards. So I can plug in 0 to my equation, right? And that'll work. Or I can just say, if I'm multiplying by 1.1, I can divide by 1.1, right? 50 divided by 1.1. It's like 45.45. So that's my initial for that one. My rate's going to stay the same, but now I can just put n. Both work. So what does this mean in real life terms? What's my interest rate? Are you interested? It's going up by 1.1 each time. 100% is 1. 0.1 is 10%. So you are paying a 10% interest each month. That's awful. Don't do that. Don't pay interest. All right. Hope that helps. Enjoy. See you.